Hello everybody, welcome to Chapter 7.1, Part B. We're still doing systems using substitution, but this chapter is going to go over, or this part of the chapter is just going to talk about the applications. You guys know that means word problems. And really what we're going to get from this lesson is we're going to understand that solutions to systems is the point where the two equations are equal to each other, and that means a lot of different things in the context of problems. And we can find things like just amounts of money. We can find where two functions kind of like break even with each other, where one function starts to exceed another function. We can find a lot of interesting things. Our first example we're going to talk about is finding an amount of interest. So we're going to title this one Interest. Okay. And our question says a total of $12,000 is invested in two funds paying 9% interest and 11% interest. The yearly interest is $1,180. And what we're finding out is how much is invested at each rate. In other words, how much money did you put in each fund? That's what we don't know yet. However, we're going to write out in words what we do know. We do know that 9% of the fund we don't know. I'm going to call this Fund X, right, because we don't know the fund, we don't know how much it is, plus 11% of Fund Y, because we don't know what that fund is. We don't know how much we put in either fund. That's going to be the total amount invested. All right, now let's work with that interest rate, right? We know that we have 9% interest plus 11% interest equals that total interest. All right, and here's the thing. What we don't know is we don't know how much was invested at 9%, and we don't know how much was invested at 11%. We don't know those amounts. So that's what we're going to label our X, Fund X, and Fund Y. We don't know Fund X, we don't know Fund Y, so we're going to say that's the total amount invested. Or pardon me, we're going to call that 12,000 because that's how much was invested total. And now we know that 9% of the X fund plus 11% of the Y fund was the total amount of interest. That was 1,180. All right, and now we've got some numbers we can sort of work with, but we can make them even easier to use. So here's what we're going to do. We're going to rewrite our system on a separate sheet of paper. And we are going to multiply the bottom one by 100 so we get easier numbers to work with. We're still going to have X plus Y equals 12,000. And we're going to start with 0.9x plus 0.11y equals 1,180. But to make these numbers easier to work with, I don't know about you, I don't really like dealing with hundredths. So what I'm going to do is I'm going to multiply both sides of this equation by 100. And remember, that's always allowed in algebra, both sides of an equation, as long as you do it to both sides. You haven't fundamentally changed the equation, you just made it easier to work with. So my new system is going to look like this. I'm going to have, I'm going to draw a little arrow, it's what we're changing it to. We're going to have x plus y equals 12,000, and when I do all this math, I get 9x plus 11y, wow, that's a lot easier, equals 1, oh, hang on, let me think about that for a second. Oh yeah, okay, 118,000. There we go. Didn't want to say that number incorrectly. Alrighty, awesome. Now, what we've got going on, we've almost, you can just kind of look at this and see that we've almost got a variable isolated in that top equation. So let's take that top equation and let's solve the top for x. I'm going to write that step in a box so we understand what happened here. Solve the top for x. That's what we're going to do. So I'm going to take the top equation, x plus y equals 12,000, and I'm going to subtract y on both sides. When I do that, I'm going to get 12,000 minus y. And oh my goodness, check it out, I've solved for x. And now I have a piece, I have something, some stuff that I can put into the bottom equation for x. So I can get rid of that x and put this stuff in. And that's exactly what I'm going to do. I'm going to substitute into the bottom. Draw a little box around that step, and let's do it. 9 times 12,000 minus y plus 11y equals 118,000. I do some distribution, and I get 108,000 minus 9y plus 11y equals 118,000. Now I'm going to do two steps at once here. I'm going to subtract my 108,000 from both sides, and I'm going to combine my negative 9y and my 11y. And when I do all that, I'm going to get 2y equals 10,000. Y equals 5,000. Fantastic. We've done half of our work. Now what we can do is we can take this and we can substitute it into the one that we solved for x, because now we can just put y right there, that 5,000 right there, and get x super fast. And let's do that. We're going to say substitute in to remaining equation, I guess I should say. Or you know, it really doesn't matter. I'm going to cut out the word remaining. I'm going to say equation. It doesn't matter. It can be either one, whatever floats your boat. I just personally think that this is a sensible thing to plug into because that's going to be really easy. All right. Let's stop talking. Let's do some math. Put 5,000 in for y. That's what it looks like. And now when I solve for x, I get 7,000. So, ... what I'm really saying with this is that, remember my 7,000 was my X fund, it was my 9% fund, so what I'm saying is $7,000 was invested at 9% interest, and $5,000 was invested at 11% interest. There we have it. All right, that's our first problem. Let's move on to the next one. We're going to talk about break-even points next. It'll be a lot of fun. So, I'm going to pause it, write the problem, then you can copy the problem down so this video takes less time. Alright, so I've written out this word problem. If you want to take a second and pause your video to write it all down, please do. But I'll read through it. A small business invests $10,000 in equipment to produce a product. each unit of the product costs 65 cents to make and is sold for $1.20. How many items must be sold in order for the business to break even? Here's what I would like to remind you of, first of all, the basic profit equation. Profit comes from revenue minus cost. And what we're interested in with this break-even point, breaking even is going to happen when profit is no longer negative, when profit is zero. Because after profit is zero, directly after that is when it's going to start to be positive. You're going to start to make some money. So the break-even point is when profit is zero. So let's fill in zero for profit. And let's see what we can do with these. If I add C on both sides, I get the equation R equals C. So really, what the break-even point means is when revenue equals cost. So what I'm going to do, first of all, is we're going to make a revenue equation and a cost equation, and we're going to call them both C, and then we're going to substitute in. So here's what we're going to do. Let's write everything out in words once more, just because it's always helpful to do. It's a good strategy, a good skill to have when you're dealing with application problems. We know revenue, the amount of money coming in, is derived from the amount made, so like money made from each item, and we multiply that by how many items are sold. And our cost includes a few different things. Not only are we talking about the cost to make each item, cost per unit, cost per item, times the number of items made, but we also have to take into account initial costs. Businesses typically don't just rise from the ground without any money being spent on them. You usually have startup costs or initial costs. So now let's fill in all of these words. We know not the number of items made or sold yet. That's going to be our variable. That's going to be our X. But we do know how much they make from each item, which is 120. And we do know that it cost them 65 cents. And we do know that initially they had to spend 10,000. So let's set it up like this. Let's set it up as R equals 1.2 X, $1.20 for the number of items I don't know. Cost is 65 cents, 0.65, times the number of items I don't know yet, plus how much they spent initially, which was a $10,000 investment. All right, so I've got two equations, great, but remember, I'm interested in, what I'm going to do with these is I'm going to find out when R equals C, when this function equals this function. So here's what I can do. I can substitute in 1.2x for C, and that's exactly what we're going to do. We're going to write that step out. So then we can truly find out when R equals C. So 1.2x equals 0.65x plus 10,000. Two-step equation, we're pretty solid with this. We should get, let me move my paper up here. We should be getting 0.55x equals 10,000. And when we do some division, we are going to find that x is approximately, I'm going to round up here, you should round up as well when you put this in your calculator, 18,182 units. And what that tells us is that we are needing to produce 18,182 units for these two functions to intersect each other, and after this amount. After making 18,182 units, we will start to make money. This is just where we stop losing money and then we make money after this. That's what break even means. All right, let's move on to the last example. Same thing, you're going to see a word problem pop up. Feel free to pause it to copy it down. Alrighty, take a second, pause your video if you'd like to write down this word problem, but I'll read through it. This one's titled Catch Up Point because that's another thing systems help us find. From 1990 to 2000, the population of Tennessee was increasing at a rate faster than the population of Missouri. Models that approximate the two populations are equals 4,866 plus 74.5 t, and P equals 5,106 plus 43.5 t, where t equals 0 corresponds to 1990. When will the population of Tennessee exceed the population of Missouri according to the models? Notice that from this problem, it doesn't matter. We don't know which one of these is Missouri and which one of these is Tennessee. That has no bearing on us finding the right answer here. The point where Tennessee is going to exceed the population of Missouri is going to be the point where these two graphs intersect. And again, we can find that by using substitution and solving the system. And you can see kind of a neat thing going on here. We have a value for P and we have another value for P. So what we can do is just take some of this stuff for P and put it in for P in the other equation. And we're going to eliminate that variable altogether, and then we'll get an equation that's going to be like 2 to 4 steps. It's not going to be too hard. So let's start doing that. We're going to substitute in one function for P. That's our first step. We'll draw a little box around it. All right. And it doesn't matter how you do it, but you should get an equation that looks like this, either with the left or right side different, but it doesn't matter. 4,866 plus 74.5 t equals 5,106 plus 43.5 t. And in about 3 steps we can solve this. If we subtract 43.5 t here, subtract 43.5 t here, subtract 4,866, subtract 4,866. When we take care of that algebra, we get that 31t equals 240. And when we divide by 31, we get t is approximately, rounding to 3 decimals, 7.742. And let's keep in mind what this means, what we've just found. We're going to do like a little dot, 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 and we're going to say t equals 0 corresponds to 1990, correct? So if 1990 is when t equals 0, when t equals 7, that must be the year 1997. And we're bigger than just 7, we're 7.742. So we can say, in the year 1997, sometime in there, right? Probably later in the year, given we're almost to 8. But sometime in 1997, the Tennessee population will exceed Missouri. And that's all we've got. We'll see you in class tomorrow. Thanks for watching.